Hi, welcome to the notes for H3-3. Today we're going to look at rational exponents. You've probably done a little bit with rational exponents back in Algebra 1, and you may not have seen it since then, so this should be a good review, and we're going to add in some new stuff to it. The first rule we're going to look at is when we take a number and we're raising it to a rational power, like 1 over b. So the first rule we're going to focus when our numerator is a 1 and we have some other number in the bottom. Remember, our denominator is going to represent our root. So when we think about this, this is always the power in the numerator and the root value in our denominator. So if our power is just 1, that means we're just focusing on the value of n. And in this case, we're going to be talking about our n, and we're going to be taking whatever root we have from our denominator. So since this is b, we'll be taking the root of b of n. Okay, you're used to seeing like 2's and 3's, the square root, the cube root. Okay, so whatever value we have there would be written up in our radical. So for instance, let's look at the bottom just so it makes a little bit more sense with some numbers. First one, obviously, we have a to the 1/4 power. So that's like saying a to the first power, and then we're going to take this root number. So we're going to say, like we're writing the square root, but we put that little 4 up here to indicate that it's the 4th root. Number 2, we have 36 to the 1/2 power. So thinking about it, right, we know 36 to the power of 0 is 1, and 36 to the first power is 36. This is going to fall somewhere between them, 36 to the 1/2 power. So we're going to take 36, just think about it like it's to the first power, and then we're going to take the square root of it. Okay, now you don't have to write the 2 out here, we usually don't, but just remember, square root means we're taking that second root. So the square root of 36 we already know is 6, so this one actually simplifies down to 6. For the third one, we have 64 to the 1/3 power. We'll take 64, remember the power is 1, and then we're taking the third root or the cube root of it. This is just asking us what number times itself 3 times gives us 64. And in this case, that would be 4. Let's move on. Next example, we have 49 to the negative 1/2 power. So we're going to mix in some of these properties of exponents that we've been practicing over the past few lessons. Remember, this one can be treated as 49 to the 1/2 power, and then we can deal with the negative afterward. So 49 to the 1/2 power is going to be like saying the square root of 49. Okay, and then we'll take it there and raise it to the negative first power after we simplify. So the square root of 49 is 7. So now it's just 7 to the negative first power. Remember, 7 is our base, so we'll just take the reciprocal of our base, which is going to make it 1/7 to the first power, which is just 1/7. The next one, we have 1/8 raised to the power of negative 1/3. Again, you can treat it like we've done with the others. We have 1/8, and I'm going to raise that to the 1/3 power, and then I'll deal with the negative in just a moment. Or, with this one, we could flip-flop that and do it like this. If you don't like fractions, we could say 1/8 to the negative first power, and then take it and raise it to the 1/3 power. How does this help us? Well, remember, if our base is 1/8 and we're raising it to that negative first power, that's going to allow us to take the reciprocal. So now it's like 8 to the first power, right? And so if I have 8 to the first power and I'm raising that to the 1/3 power, I know that's like saying the cube root of 8, which we know is going to be 2, right? 2 times 2 times 2 is 8. If you did it the other way that we started doing there, right, we're talking about doing the cube root of 1/8, and it's still being raised to the negative first power. Remember, if I'm doing the cube root of a fraction, that's like saying the cube root of the top over the cube root of the bottom. And both of those are perfect cubes. The cube root of 1 is 1. The cube root of 8 is 2. So we have 1/2 to the negative first power, which means we're going to take our base and use its reciprocal to make it 2 to the positive first. And you'll see we get 2 there, just like we did over here. Next expression is when we have a different value besides 1 in our numerator. So if I have some base n and it's being raised to the power of a over our b, okay, we're still talking about our root value is b, but now instead of raising it to just the first power, right, we're going to be raising our base to whatever power is left in the numerator. Okay, so there's 2 ways to write this. You'll notice this first example, we have, if we were following the order of operations, we'd raise it to the power of a, and then we would take the root of b. But we could also take it and do our root first, and then raise it to the power. So you see that in the second one here, right? We're going to take the root of whatever b is of n, and then we're going to take it and raise it to the power of a. That works the same way as the middle step. So let's look at a couple of these to figure out what's going to happen. If I looked at this first one, I could treat this as 36 to the third power and then raise it to the 1/2 power, right? Because isn't 3 times 1/2 3 halves? Or I could do 36 to the 1/2 power and then raise that to the third power. That's also going to give me 3 halves when I multiply them. Well, which one can I do in my head? 36 to the third power or 36 to the 1/2 power? I know 36 to the 1/2 power is just 6, right? I don't know what 36 to the third power is in my head, so I'm going to go with this bottom one. I've done 36 to the 1/2 power is 6, and now I can raise it to the third power, which gives me 216. So either order would work. I just can't do 36 to the third power in my head. If I wanted to figure out what that was, I can just pull out my calculator and do it. Let's see, I'll do it here real quick. I have 36 to the third power is 46,656. So you can see that's a big number. And then if I'm taking that and raising it to the 1/2 power, it's like saying the square root of all of this. And when you do that, you'll get 216 out. Just way harder to do that in your head. Let's look at number 2, 27 to the 4/3 power. Okay, so we can either say this is 27 to the 4th power, then being raised to the 1/3 power, which is like saying the cube root of 27 to the 4th. Or we could say this is 27 to the 1/3 power, and then we're going to raise it to the 4th power. So the cube root of 27 raised to the 4th. To me, that's going to be a little bit easier to do. Cube root of 27 is 3. 3 to the 4th is going to be 81. All right, last one on this page, we have 32 to the negative 3/5 power. So I'm going to use my negative exponent at the end like we've been doing in previous problems. So I'm going to think of this as either 32 to the third power and then to the 1/5, which is like saying the 5th root of 32 to the third. And then we'd also still have to raise that to the negative first. Or you could say 32 to the 1/5 power, and then you're going to raise that to the third power. And then you would also, have to deal with your -1. For me, that's going to be easier to do because I know that the 5th root of 32 is going to be 2. Right, so this value here ends up being 2. So I have 2 to the third power, and then I'm going to raise it to the negative first. Well, 2 to the third is 8, and 8 to the negative first is going to give us a 1/8 as our answer. Okay, so remember with this one, there are 2 options. There's this option and there's this option. For me, it's usually easier to go with the second option, like we did on each of these so you can see that. All right, so here's a few just to write them down, practice. If I have a to the 3/4 power, I know that it's either going to be the 4th root of a to the 3rd, or it's going to be the 4th root of a, and then we're raising that to the 3rd power. Next one, we have x to the 5/2 power. So we could say with this one, it's either going to be the square root of x to the 5th, or we're going to say the square root of x, and then we're going to raise it to the 5th power. And now if we still need to simplify that one, this one we could actually simplify more, right? X to the 5th power. Okay, if we're taking the square root of that, that's like saying x to the 4th times x. And we could break that apart and say the square root of x to the 4th times the square root of x. And the square root of x to the 4th, right, is going to be x squared. So we have x squared times the square root of x. Let's look at number 6, haha, but we have a 9. So 9 to the 1/2 power is the same thing as 9 to the 3/2, which means we're going to be taking the square root of 9 and then raising it to the 3rd power, or we could say the square root of 9 to the 3rd power. For me, I can't do 9 to the 3rd power in my head, so I'm going to stick with the top one. I'm going to say here that square root of 9 is 3, and then 3 to the 3rd is going to end up giving me 27. The directions on the next one state, rewrite each expression as a single radical. To do this, we need to try to combine our statements together. For number 1, I have x to the 2/3 times x to the 5/3. Well, using my property of exponents, I know I can do 2/3 plus 5/3 because I'm multiplying two numbers with the same base. When I add those exponents, I get x to the 7/3. Okay, now it says to write it as a single radical. All right, well, in this case here, if I'm trying to write it out as a single radical, I know my radical comes from the bottom, so it's going to be like saying the cube root of x to the 7th. Okay, or we could say on this one, the cube root of x and then raised to the 7th. Either one of those is correct. It's not completely simplified. We could simplify it a little bit more, but I would say I would go with that just to satisfy the directions that are given. Let's go with number 2. I have y to the 5/6. That's a negative 5/6. So let's just pull that negative and put it out here for the moment. I know that y to the 5/6 is going to be saying the 6th root of y to the 5th. And if I'm raising that to the negative 1st power, since it's my base, it will move to our denominator and say 1 over the 6th root of y to the 5th. And now it's all to the positive 1st, right? So we'll just keep it as 1 over the 6th root of y to the 5th. Again, could it be simplified a little bit more or rewritten a little bit differently? Yes, but that's not what we're working on right now. Number 3, we have x to the 1/2 times x to the 3/4 times x to the 1/5. If I want a single radical, right, I need to make sure that I've got the same root for each of them. Each of these has a different root value. But because they're fractions, we can rewrite them so they have a common denominator. In this case, 2, 4, and 5 all go into 20. So I can rewrite this as x to the 10/20 times x to the 15/20 times x to the 4/20. And now we'll just use that property of exponents that states that we can multiply numbers with the same base and add their exponents. So that's going to be x to the 29/20. And if we want to write it as a single radical, we know that the root we're taking is going to be this denominator, the 20. So we're going to say this is the 20th root of x to the 29th power. Again, does it simplify down more? Yes, it does, but we've got it to a single radical, and I'm okay with that for right now. Let's move on to another one. Rewrite each expression as a single radical again, so a couple more practice problems with this concept. I have 4 to the 1/3 times a to the 1/2 times b to the 5/6. So these ones have different bases, so that's really important to notice. Right? We've got a different base on each of these. Okay, so if I still want to write it as a single radical, I still can write them all under the same root. We just need to get the same root for each of these. So I have thirds, halves, and sixths. To do this, let's try to make the same root. So if I'm trying to get the same root, that means I'm going to have the same denominator. So we have thirds, halves, and sixths. So I know that 3 and 2 both go into 6. So let's rewrite each of these out of 6. So 1/3 is the same as 2/6 times a to the 3/6 times b to the 5/6. That one didn't even have to change. So we could think about this now as 4 squared times a to the 3rd times b to the 5th, all being raised to the 1/6. Because remember, if I am multiplying all these together as one big product, I can take this power and like distribute it through my terms. I'm just going backwards. It's like I've factored out a 1/6. If we simplify the inside, we've got 16 a to the 3rd, b to the 5th. And if this is all to the 1/6 power, we can rewrite it as the 6th root of 16 a to the 3rd, b to the 5th. And the last one, we have xy to the negative 1/8. Remember, this is x to the positive first, y to the negative 1/8. So the x isn't really moving anywhere. We could take our y and move it down to the denominator and say this is like x times 1 over y to the 1/8 power. Okay, well, y to the 1/8 power is talking about the 8th root. So we have x times 1 over the 8th root of y. And now let's just combine it into one expression. We have x over the 8th root of y. We've got it written as an expression with a single radical. Last two, rewrite each expression as a single radical one more time. So with this one, our key here is I think we want to end up with the same bases. So with this one, we've got a 16, we've got a 2, and then remember we're dividing here. So if I'm doing the 8th root of 16, let's think about this instead as the 8th root of 16 equaling 2 to the 4th. On the bottom, I don't want to change my 2, so I'm going to say the 6th root of just 2. And if we took this and rewrote this as fractions, okay, let's think about that for a moment. This is like saying 2 to the 4/8 power over 2 to the 1/6 power. So now I'm dividing two numbers with the same base. We can take this and rewrite this as 2 to the 4/8 minus 1/6, or I can rewrite my 4/8 as 1/2 minus 1/6. Because when we divide two numbers with the same base, we can subtract the exponents. Now when we get a common denominator, we've got 2 to the 3/6 minus 1/6 is going to be 2 to the 2/6, or 2 to the 1/3, which when we take it and simplify, it's going to give us the cube root of 2. So these are great problems to look at using all of your different exponent properties and rules. Let's look at the next one. We have the 10th root of 32 and the 8th root of 4. Okay, so 32 and 4 can be rewritten as the same base, right? 2 goes into each of those. So we're going to say the 10th root of 2 to the 5th power is 32 over the 8th root of, let's see, if I want to turn 4 into 2, that'd be like a 2 squared. And now we can rewrite these as 2 to the 5/10, which is 2 to the 1/2. And on the bottom, we have 2 to the 2/8, which is like 2 to the 1/4. And maybe I shouldn't have reduced that top one there. We need them to be in fourths, it looks like. So, or actually, let's just do it this way, right? Again, we are dividing two numbers with the same base. Let's just subtract the exponents. 2 to the 1/2 minus 1/4. A half minus a fourth is going to be a fourth. So 2 to the 1/4, which is written as the 4th root of 2. And those are the answers. So this stuff is hard. You need to ask questions if you don't understand. If you didn't even attempt the notes or you didn't write this down, okay, we can't help you. Okay, you have to put the effort in to try to understand the problems. All right, thanks for watching.